We use electricity several times a day. But what exactly is electricity? Is it a current? Is it a charge? Let us try to understand the complete concept of electricity. So, to start with, I have a simple circuit over here with a bulb and a battery. A switch is not yet closed. When I close the switch, we say the current flows through this circuit and the bulb glows. Now, to understand what exactly happens inside this circuit, how this current exactly flows, we have to understand the concept of atomic structure. Let us consider a structure of an atom. What is inside the atom? Inside the atom, in the nucleus, there are two type of charges present. So, those are, we can say, this we will consider the positive charges and we call it as proton. And these charges we are representing them with neutral charges. These are the neutral charges in the nucleus and called neutrons. While outside this nucleus in the orbit there are few charges present. Those are roaming here, those are rotating here, and we are calling them as electrons, and those are the negative charges called electrons. So this is basic structure of an atom. We have to remember the charges those are present over here in outer orbits. That means the electrons those are present over here plays a vital role in the flow of current or in the concept of electricity. So to make you understand this better way, now let us move to the further circuit. In this situation, when the switch is opened, we can say inside the conductor there are charges. As we know, there are positive charges, there are negative charges as well, and there are some neutral charges as well, but these charges are not having any force present over there, or these charges are moving in certain directions. The direction is not fixed, they are moving in any direction. What happens here is, the moment we close this switch, the positive charges present over this plate and the negative charges present over this negative plate of the battery plays an important role. What happens? These positive charges start moving in this direction and the negative charges start moving in this direction due to the electromotive force of the battery. So negative charges are moving in this direction. So these negative charges are completing their path through the circuit and coming to the positive plate, and these positive charges are moving through the circuit through the conductor and completing their path coming back to the negative plate. And this flow of charges, this flow of electrons in one particular direction, this flow of protons in one particular direction, we are calling this as electric current. One thing is clear, the current is having relation with the charge. So the relation between the charge and current is I, current I is equals to Q by T, and the unit is in amperes. Here current I, we are considering it as average current. Q is charge which is transferred during the flow of current, and T is time in which the current is transferred. So if we consider, say, we can say 1 ampere of current, 1 ampere of current is flowing through a particular circuit in 1 second of the time, 1 unit of the time, that is 1 second of the time, then we can say that this calculations comes to be 1 ampere is equals to the flow of 6.24 into 10 raised to 8 electrons per second. These many electrons have to pass through the conductor in 1 second to contribute 1 ampere of current. Let us try to understand any two particles with similar charge, when they brought near each other, say two positive charges or two negative charges, they have the tendency to oppose each other. And while the opposite charges, when they are brought near each other, they have the tendency to attract each other. So it means both the charges, those are having either positive or negative charge, are having the tendency to do the work. And this work done by the charges, we are calling this as potential. And how it is defined? The electric potential, or which is also called voltage, say electric potential E, or which is equals to V, is equals to W divided by Q, where W is work done by the charge, W is work done by the charge, and Q is the charge which has done the work. The unit of potential difference comes to be in volt, which is 1 volt of voltage is equals to the work done by 1 coulomb of charge. As coulomb is SI unit of charge, it is work done by 1 coulomb of charge. We are calling it as 1 volt of voltage or potential. Now, if you understood what is potential, then we have to understand the potential difference. As the word gives us the idea, potential difference. What is this potential difference? It is difference between the potential of any 2 points in the electric circuit. So if there is electric circuit having one resistance, one switch, and a battery connected over here, we can say that in this circuit, whenever the switch is closed, the current is flowing. The difference between potential of any 2 points, these 2 points we can consider either, or these 2 points we can consider either, say A, B. So the potential difference is always VAB, which is equals to potential at point A, VA, minus potential at point B, that is VB. So difference between potential of 2 points, we are calling it as potential difference. So combining all this concept, I hope you understand what electricity is, how a current flows through the circuit, and how the bulb gets on. This total phenomenon, all the concepts present in this, we are calling it as electricity. So if you understood the concept, please like and share this video. Thank you.